In the previous lecture, we discussed direct addressing, in which we use the value of the key itself to select a slot in the table. Now we'll modify this direct addressing method so that space is not wasted and still we can use the value of the key to find out its address in the array. Now to do this, we'll require some sort of procedure that can convert the key into an integer within a given range. And we'll use this converted value as the index of the array. So basically we need a procedure that can convert a big number to a small number. For example, where we need to convert these 5-digit roll numbers into smaller numbers that lie in range 0 to 99. If we do this conversion, then we can take an array of size 100 and store the student records in that array. So what we'll do, instead of taking the key equal to the array index, we'll take the new converted value as the index of the array. This process of converting a key to an address is called hashing. And to do this, we need a hash function. So what is a hash function? It is a function that is used to convert a key value to an address. This hash function will take a key as an input and it will return hash value of that key. And this hash value is used as the address for storing the key in the array. Now keys can be of any types like integers, strings, but this hash value will always be an integer because it denotes the address where we need to store the record. Now mathematically we can write a hash function like this, where h is the hash function, k is the key and a is the hash value of the key k. In direct addressing, we stored the key k at index k of the array. But now we'll store the key k at index a of the array. This a is also known as this key's home address. So this hash function maps the key to a smaller integer, which is used as the address. And by address we mean index of the array. So we can say that hash function h is a mapping from universe of keys to the slots of a hash table. And this process of generating an address from a key is called hashing the key. And a hash table is the array in which the records are stored and retrieved using this process of hashing. Now let's see the procedure for storing and retrieving records using a hash function. First we create an array A of size m. This array A is our hash table and it has slots from 0 to m-1. Then we'll choose a hash function h, which is a mapping from keys into integers from 0 to m-1. Now to insert a record in the hash table, we'll generate an address by applying hash function to the key and then we'll insert the record at that address. Now to retrieve a record, we'll apply the same hash function to the key and then access the record at the address given by the hash function. We have seen that in direct address tables, any key k is mapped to slot ak, while here in hash tables, any key k maps to slot a hk. Now let's go back to our example of student records. Now here first we create a hash table of size 100. So it has slots from 0 to 99. Now we need a hash function that can map these keys to integers within the range 0 to 99. Suppose we take a hash function that takes a key and returns last 2 digits of that key. For example, if we have this roll number 81835, then its hash value would be 35. And so the record of this student will be stored at index 35 of this array. So using this hash function, we'll have addresses in the range 0 to 99 only. Now let's insert these records in this hash table. Hash value for this key is 11. So it will be stored at index 11 of this array. Hash value for this key is 98. So it will be stored at index 98 of this array. Hash value for this record is 5. So it will be stored at index 5 of this array. And similarly, other records will be stored. Now retrieving a record is also simple. If we want to access record of a student with this roll number, then first we generate the address using the same hash function. Now we can directly go to index 98 and retrieve the record. So this is how hashing is done, and records are stored and retrieved from a hash table. Now while using hash function to generate addresses, we can encounter a problem. In the next lecture, we'll see what that problem is.